We all knew this, but now there is research to actually prove it. LLMs can get lost in conversation. That's right. If you're going to converse with an LLM, it's highly likely that it's going to get lost. So, welcome to the series on decoding papers with AI as part of the Lax AI channel. So, today, what we're going to do is we're going to look into a paper by Microsoft Research and Salesforce Research. The paper is titled LLMs Get Lost in Multi-Turn Conversation. So, let's jump right in. So, here's the paper with a catchy title LLMs Get Lost in Multi-Turn Conversation from Microsoft Research and Salesforce Research. And it's not a new paper, it's about a year old, 2025. And it also already has more than 190 citations. So, what we're going to do today is that, as always, I've not read this paper, by the way. So, we're going to use AI tools to help us decode the paper and give us a high-level overview of the paper. And then maybe we can go into it a little bit and see what the paper is about. It's a 36-page paper, by the way, so let's see what happens. So first, what I'm going to do is, as always, I'm going to use Saral AI, which is accessible at saral.democratizedresearch.in. And then I'll go and click on Saralify, and then just sign in with a Google account. And Saral AI, by the way, is a tool to convert papers into engaging formats like videos, PowerPoints, podcasts, and other formats as well. The first step is you log in with the Google account. So once you're logged in, you can either configure your own keys or just press skip for now, which will use the system keys. And then I'm going to click on upload PDF document. I've already saved this document, and I'm going to just click on upload PDF. And once that's done, what it usually do is that we have one-click video, one-click podcast, and all other one-click reels and so on. So first, what I'm going to do is I'm going to click on one-click podcast. That gives me a rough overview. So let me do that. So there's lots of languages. I'm just going to choose English. It's going to take a while for this to complete. So let's just, the podcast is completed. So let's just start playing. It's a 4-minute, 23 seconds podcast. I'm not sure if it is able to capture the whole 36 pages of the paper, but let's see.
Hey Rohan, ready to dive into this LLM paper? The one about getting lost in conversation?
Absolutely, Aisha. Sounds like something we've all experienced, right? LLM is going off the rails.
Totally. The paper's called LLMs Get Lost in Multi-Turn Conversation. Intriguing title, huh?
Definitely. So, what's the core idea they're exploring?
Basically, they're saying LLMs are way worse at multi-turn conversations than we think.
Worse how? I mean, ChatGPT seems pretty good at keeping track sometimes.
That's the thing. It seems good, but they found performance drop significantly, like 39% on average.
Whoa, that's a massive drop. So, they tested this systematically?
Yeah, they ran a bunch of simulated conversations and compared single turn versus multi turn performance.
Simulated conversations. How does that even work?
They use something called sharded simulation. Imagine taking a single instruction and breaking it into pieces.
Okay, I'm following, like, giving the LLM information bit by bit.
Exactly. Each turn reveals only a small shard of the original instruction.
Smart. So it mimics real life conversations where we don't give all the details at once.
Precisely factorial. And they found that LLMs struggle to integrate those pieces effectively.
Makes sense. So, what were the tasks the LLMs were trying to do?
They use 6 generation tasks. The paper doesn't detail them specifically, though.
Okay, so big picture LLMs struggle when instructions are given incrementally. What's causing this?
They broke it down into 2 things: loss of.
So I was just going through the paper as we listen to the podcast. So this is what I think they meant by shard, is that if this is an instruction, this is a sharded instruction, meaning that you're dividing it into many parts, small parts. So I think that's what they were trying to that's what the paper, this is what this, how it was kind of evaluated.
Of aptitude and increased unreliability.
Aptitude, I get. Maybe they just can't solve the complex problem where it is chunked. But what's unreliability?
is the gap between their best case and worst case performance in multi-turn settings.
So they're inconsistent. Sometimes they nail it, sometimes they completely fail.
Exactly. They call it the lost in conversation phenomenon.
I love that. So, what are the LLMs doing wrong that makes them get lost?
A few things. They tend to make assumptions early on.
And then run with those assumptions, even if they're wrong?
Yep, factorial. And they try to generate final solutions prematurely. They jump the gun factorial.
Impatient written models, aren't they?
Haha, totally. Plus, they overly rely on previous incorrect answer attempts.
So, they double down on their mistakes instead of correcting them. Yikes.
Precisely. It's like they get stuck in a rut and can't climb out.
So, what models did they test? Which ones got most lost?
They tested 15 models, both open and closed weight, from LLA MA3 to Gemini 2.5 Pro.
Wow, a good range.
So I think LLMA is the Llama models from Meta, and I wonder what factorial is about. I mean, I was listening to that. Maybe is it taking exclamation as factorial? Quite possible.
And even the best ones struggled?
Yep, they all showed significant performance drops in multi-turn conversations.
Okay, so what's the takeaway? What are the implications of this research?
It highlights a big gap between how we use LLMs and how we evaluate them.
Meaning we're not testing them in realistic conversational scenarios?
Exactly. And that could be why AI adoption is lower than expected, especially for new users.
Because they get frustrated when the LLM goes off track. Makes sense.
Right. The paper urges LLM builders to prioritize multi-turn reliability in future models.
So focus on making them better listeners and more adaptable to changing information.
Exactly. It's not just about raw power, it's about being a good conversational partner.
Makes you wonder how they can fix this more training data for multi-turn stuff.
Probably. Maybe also better mechanisms for error correction and backtracking.
Definitely, this paper's a good wake-up call. LLMs have a ways to go.
Absolutely. It's a really important area for future research and development.
Agreed. Thanks for walking me through it, Aisha. Super interesting.
Anytime, Rohan. Always fun to chat about the quirks of our AI overlords, assistants.
That's it. That was a quick overview. And then it's nice to see that I know it was 36 pages, but we are on page 13 and the paper is already done. So mostly the remainder of the paper is references and appendix. And then interestingly, they've only done it on English language. So when you go to like other languages, say India, for example, has lots of other languages, things get even more tricky. And if the accuracy is so low, even just for English, which is most commonly used, then imagine for other languages, things are going to get even worse, right? So a very interesting paper. A nice podcast, which just gave a quick 1-minute overview on the whole thing. Yeah, so the podcast gave a good overview. So now I'm NotebookLM, which is also generated video overview. So let's go and find out what NotebookLM is going to tell about this paper.
Okay, so you've been there, right? You're deep in a conversation with a chatbot, everything's going great, you're making real progress, and then poof, it's like it has total amnesia and completely forgets what you were just talking about. It's so frustrating. And today, we are going to get into exactly why that happens. You know the feeling. You start a chat, you're carefully laying out your idea piece by piece, but the AI just doesn't seem to be keeping up. You end up repeating yourself, or worse, it just flies off on some totally bizarre tangent. Sound familiar? Yeah.
Yeah, absolutely. That's happened to me so many times. So sometimes it just gets stuck in a loop, or it just constantly keeps giving bad answers. And many of the times, what I do is just restart the whole conversation, which is painful in some ways, but that's seriously a problem with today's large language models. It is definitely better, keeps getting better than before, but still, it's a problem.
I thought so. Because it always starts so well, doesn't it? You kick things off with a simple request, and the AI totally gets it. The first response is perfect. You're sitting there thinking, wow, okay, this is incredible. It really feels like you're working with this super intelligent partner that's ready to help you build something amazing. But then, a few messages later, you add one tiny new detail, maybe a simple little clarification, and the whole thing just completely derails. Suddenly, the AI acts like it's never seen your earlier messages, ignoring all the context you've so carefully built up. Seriously, what is going on here?
Well, let me tell you, you are not crazy and you're not imagining things. This is a real, totally measurable problem. In fact, some brilliant researchers from Microsoft and Salesforce just put out a fascinating paper that proves that even the most advanced AI models today get lost in conversation.
So just notice one small detail. This is why, again, NotebookLM and the tools that it uses are just absolutely really, really cool, and also very. I mean, it's if sometimes I'm loss of words. So it said that this paper is from researchers of Microsoft and Salesforce, right? So look at how it depicts them. So it's put one person here and one person here, and then it also adds this small detail. This looks like a Microsoft logo, and this looks like a Salesforce logo. So it's like what is so cool in this that even that minute detail, it's kind of added here, and so that also adds to the illustration. So I always like paying attention to detail. So this is one of them, and just wanted to appreciate that.
So, what did they find?
All right, first things first, let's put a name to this whole experience. The researchers zeroed in on this core disconnect between how we talk and how AI is typically tested. And that name is underspecification. I mean, just think about it for a second. When you ask a friend for a favor, you don't hand them a perfectly written 5-paragraph legal document outlining your request, right? No. You start with a basic idea, and then you fill in the details as you go. It's just a natural, super efficient way for us humans to talk. But for an AI, that gradual reveal is a massive, massive challenge. So the big question is, how do you scientifically prove a chatbot is getting confused? You can't just have a few chats and call it a day. No way. You need to test this stuff at a huge scale. And the way these researchers pulled it off was, honestly, pretty ingenious. They came up with this really clever method. What they did was they took these standard AI test questions, which are normally these single, super long, detailed prompts, and they just chopped them up to make it look like a real back-and-forth conversation. And here's exactly what that looked like. On the left, you've got your classic AI prompt. Every single detail is given right at the start. But look at the right. That's what they called their sharded version. It is the exact same information, just broken up into 5 little conversational messages, just like a real chat. And that one simple change, well, that was the key to their entire experiment.
And get this, they weren't just testing simple math problems. They applied this whole sharding method across 6 completely different complex tasks. We're talking everything from generating Python code and SQL queries to writing summaries and even calling APIs. This just proves that the problem is fundamental. It's not just tied to one specific kind of request.
Okay, so the stage is set. They've got their massive simulation ready to go. They have the single prompt tests versus the multi-turn chat tests. So, what happened? This is where things get really, really eye-opening. The difference they found wasn't small. It wasn't just a little dip here and there. No. The drop in the AI's ability to get the right answer when it was in a conversation was absolutely staggering. And here it is, the big headline number. Across every model and all 6 of those complex tasks, they saw an average performance drop of 39% whenever the request was made conversationally. I mean, that is a huge difference. So what on earth is actually going on under the hood? So the researchers dug in even deeper, and this part is so crucial. The AI's raw skill, what they call aptitude, only dropped by about 15%. The real killer was unreliability, which went through the roof, skyrocketing by 112%. What this means is that the AI didn't just get a little bit dumber, it became wildly unpredictable.
That's really interesting. So I'm guessing unreliability means that your answer need not be necessarily wrong, but it could just be not that as it could be irrelevant or not as reliable or relevant as possible. So that's interesting to see there.
Would sometimes get the answer right, and then other times fail spectacularly on the exact same task. This quote from the paper just says it all perfectly. Once an AI takes a wrong turn early in a conversation, it has an incredibly difficult time finding its way back. It gets lost, and it stays lost. So, to put it as simply as possible, if you're one of those prompt engineers who can write that perfect, single, detailed request all at once, you're probably going to get a pretty reliable answer. But if you're just a normal person trying to have a normal conversation, the AI's reliability can just completely fall apart. So let's get to the big question, the why. The research didn't just spot the problem, it also diagnosed the very specific causes. So what are these wrong turns that the AI keeps taking? They pointed to 4 key failure modes, and I bet these are going to sound very familiar. First, the AI just gets way too chatty, burying the actual answer in a mountain of fluff. Second, it's just too eager. It tries to give you a final answer before it even has all the details. Third, it makes bad assumptions to try and fill in the blanks. And finally, it gets stubborn, sticking to its first wrong answer no matter how many times you try to correct it. Yeah, that tendency for the AI to jump the gun and give you an answer prematurely is a huge reason it fails. It's almost like it commits to a path way too early, and then it really struggles to admit it was wrong and change course when you give it more clues later on. Really understanding this problem is the very first step toward actually fixing it. So, what does this all mean for the future of AI and, well, for all of us trying to use it? This research is just so important because it explains a really common source of frustration for users. Look, if you're not an expert at writing these perfect, long-winded prompts, and let's be honest, most of us aren't, you are way more likely to hit this lost in conversation wall, which can just make you feel like the whole technology is broken. But here's the good news. There is hope. The researchers actually tested a really simple fix. After one of these multi-turn conversations, they just added one last message that recapped all the instructions in a single prompt. And guess what? Performance shot right back up. This suggests that building better memory and summarization tools right into these systems could be a really powerful solution. This research really shines a bright light on a massive hurdle for conversational AI. The challenge isn't just about being smarter, it's about becoming a better listener, patiently gathering all the context before jumping to a conclusion. And it leaves us with this really fascinating question for the future of this tech. Will the next generation of AI finally learn how to listen? Thanks for tuning in to this explainer.
That was it with today's paper, like LLMs get lost in multi-turn conversation and why it's happening and how to simulate that by using a nice method called sharding. And then also like what could be some potential ways forward, fixes to that. So like I said, I have not read the full paper, just whatever I read on along with this video. But that gives some high-level overview on what's possible. And if I read the paper now, that'll hopefully help me to understand better. So until next time.